Love it. I'm gonna show Pat.
So cute.
That's Hodor the Magnificent for any
His
of
eyes
you
are
who don't know.
beautiful.
Yeah, isn't he awesome? He's
Please.
This
he's
is
my
cool
supervisor.
cat.
All right, so let's start off with the basics. Let me see if I can make this happen here. Oh, look at that. I love it when it works. Everybody in the room that I see so far knows the Emily. Is that Emily Mintz? Hello. So I'm going to start with the basics, work my way through, and make sure that I take attendance at the end so that if people hop on, that I make sure all you guys get paid. All right. So, making sure that you're setting up the instrument, a few of you actually that are on the screen right now are studying for COT. And when you do your COT practical, there's a very specific order of operations that you have to do. And even though you could do it in a different order, practically, and it would work out fine in the clinic, if you do it in the wrong order on the test, in practical, you fail the entire unit. So might as well start from the very beginning with that one. We're going to start at the top by leveling the instrument, and then we're going to enter that pupillary distance. If we have a choice of going by the AR or their wearing RX, we're always going to put their wearing RX in because that's what they're used to seeing, whether it's right, wrong, or indifferent. That's what they're used to seeing every day. So they'll appreciate a change better than if we start them with an auto refraction that doesn't match their glasses. And so we've already made a change to what they're seeing. So I prefer to put in what they're used to wearing. We want to remember that you're going to do all of this stuff in order. We're going to check their sphere first. We're going to check the axis second. Do not check cylinder power before you check the axis. We need to refine the axis first. And then we're going to check the power of the cylinder using the Jackson cross for the axis and the cylinder check. When you are doing distance, you're going to make sure that those levers up there are out. Sometimes when you turn, like when you turn the phoropter to go enter a prescription in there, sometimes when you turn it back, that lever, when you turn it back, will flop itself in. And you think that I did that like for a great educational thing, but I turned it to put something in there and then I took the picture and didn't realize it was in there. So you want to make sure that you start at the top, and this is COT practical order, starting at the top, leveling the instrument, enter the pupillary distance, be sure the levers are out for distance.
Now, Sherry, when you say pupillary distance, are you taking the AR?
Yes.
Pupillary distance?
I usually do. Because in my opinion, that's the only thing an AR is good for. But it's really important that when you are doing distance that the levers are out. I'm using the PD off the AR. If you need to, there's a millimeter measurement on the back of the near cards too. So if you prefer to do it by hand, you can just take the near card, lay it across their forehead and slide it down until half their pupils are covered and measure it that way.
Here, Sherry, just
yes,
like this. And starting from here, how about the puberty distance? One or this way? How?
I prefer the AR, but if you happen to be in a situation where you don't have access to it, that is another way to do it. In the tech, in what we do, there's often more than one way to do things correctly. What we're looking for here is standardization. So keeping in mind that the spherical setting is the big sphere, the big global dial there. It shows in that window, and I don't think any of our offices have any of the fancy phoropters that have digital stuff. It's all manual. When you start when you start checking sphere, we're always going to start by pulling into the plus, and I try to train people to put their finger right up there in the corner. And when they're popping down 2 clicks, leave your finger on the dial in case the clicks get weird. You can always anchor it right back up at the top and start again. So when you're pulling that from the top down, you're moving towards the plus. When you move the wheel from the bottom up, you're moving towards the minus. Cylinder setting is the outer ring. Do I have any, I don't think I have any really non-refracting text here, but I'm going to go through it anyways. That outer ring is the axis setting, and the cylinder shaped knob that sticks out and looks like a cylinder is your cylinder knob. I like to make sure that when you are putting this thing in front of your patient that you're grabbing these 2 prism things on the side over here, putting it in front of your patient and literally getting it eye level with the patient, looking at their pupils in between there, to make sure that their pupils are centered, that they're not all bent over and, you know, they're sitting comfortably and all of that, and that the little white headrest thing is touching their head. If it's too far out or too far in, you can adjust that little white headrest with this knob here. And you can also peek into these little prisms. They're like periscopes. You can peek into those guys to see the patient from the side. You can see if their head is up against the thing without going out behind them. Make sure that if you tighten your phoropter, that sometimes when you tighten it and you let it go, it pops up like a 1/4 of an inch. So make sure that if it does that, you don't have to readjust the phoropter, just lift the chair a 1/4 of an inch. Put your patient.
I hate that, and it happens all the time, especially with the ones that like need the WD-40 on it.
Uh-huh.
I always tell patients, I'm like, and bear with me, this machine's a little persnickety. Or I'll say, oh, this doesn't like me very much today, so bear with me.
Try leaving it right where it is and just popping the chair up a tiny bit. Just remember to put the chair back down, you know?
Well, that would be something I wouldn't do.
Yeah, right. But in this case, it's not like you're a giant tall technician and you're trying to work on a tiny little patient. You're just making an adjustment of that like 1/2 inch pop-up that the thing does, you know, and that way you can move the chair around and you're not slamming the patient in the face with a big black metal machine.
If only all the chairs were the same though, because like those Yarmouth chairs, trying to get some of those up
Tough
is
enough,
rough.
Cupcake, come on. We want to make sure your patient isn't leaning or straining, because as soon as they stretch to get into the phoropter, you'll be 2 clicks into the sphere and they'll start to relax and come away from the headrest and all that. And that would be like, for those of you that wear glasses, that's like taking your glasses and pulling them away from your face. They don't work as well that way. Make sure they can identify the chart so that they're not looking at some sign on the door somewhere. We're going to occlude the left eye and make sure that you're letting your patient know to keep both eyes open. And if they have those expensive lash extensions, make sure they sit back before you snap that guillotine down on their $600 lashes. And just a little talk about what it is we're doing when we're checking their sphere power. What we're doing is we're taking a focal point, we're either moving it forward or backwards, right? We're either moving that focal point towards the patient using plus, or we're moving it away from the patient using minus to make it land in the right spot. A 1 diopter plus lens focuses at 1 meter. And it's reciprocal fractions from there. So 2 diopter lens, you just throw a 1 over the 2 diopters and you've got a 1/2 meter, 3 diopters, a 1/3 meter, and so on. So the bigger the number, the bigger the plus number, the shorter the focal distance. So if you've got somebody with a, say, 24 millimeter eye, you're probably gonna replace that cataract with a plus 19 to give you that 23 millimeters instead of, you know, we're not talking meters. So with myopia, the eye is long, and we need to use minus power, less plus, to diverge those rays, to take a focal point and move it further back where it belongs. In the hyperopic patients, they've got the short eyes, right? Your 22 millimeter, 21 millimeter or shorter eyes. And the focal point's too far. It's too far back behind them. And so we're adding plus lenses to shorten the focal distance by converging those rays using a magnifying glass, basically, and moving that focal point up where it lands on the retina. So you see the technicians walking around looking through, pick the pair of glasses up and look at them, hold them away from you, look up, see if you can find the ad. If things are big and blurry, they're plus. If they're small and tight and narrow, they're minus. And if you tip the glasses back and forth, you can see if there's astigmatic correction in there because the image does that whoop-de-doo thing. That just makes it all easier to figure out. So the more you can figure out about the glasses before you even start reading them, the more you know about your patient already. You know, you can kind of see the angle of astigmatism if you tip the glasses back and forth. So we're going to go a line or two above their best read, and we're always going to start by putting them into the plus to fog them a little bit or relax their accommodation as much as we can. Better 1, better 2, right? Bringing it down and back. Or for those of you that prefer to hold still and say, this is 1, and then bringing it down, this is 2. Whatever it is that you do, that's fine. You just have to make sure that you're using the same technique all the time. Otherwise, you start confusing the patient and your hand will get confused too. We're going to give them plus until they won't take it anymore, right? We're going to accentuate the positive, be happy, be hyper, be plus, right? We want more. And we're only going to give them minus when they've rejected plus, right? So we're going to start with 2 clicks into the plus, and you go better 1, better 2, and they're like, okay, I like that plus, so you give it to them. You give them more plus, better 1, better 2, and they go, oh, I like that plus, you give it to them. You give them more plus, better 1, better 2, no, they don't like it. That's the only time you can start giving them minus, because by making them go to the plus where they actually reject it, relaxes that accommodation enough where you can get a better, more accurate refraction because they're not using those ciliary muscles. So once we do start offering them minus, we're only going to give them, they go, oh yeah, I like that better. But if it doesn't make them actually see a line better, don't give it to them. We're only going to give them minus if it actually makes that better. So say my best read is 20/30. I'll go up to the 20/50 line and start my refracting, pushing them into the plus. If they decide that they want minus and I'm giving them a click of minus, I'm going to take it a line below that 20/30 to make sure that that click of minus helps them. If it doesn't, don't give it, because it's probably not that they need minus sphere. It might be, you know, an axis thing or a sill thing. What we're trying to get them to is 20/20 or Wendy, I think it might even have been you that sent me an email one day saying, don't forget to tell the trainees that you can't always get somebody to 20/20. You know, they get all frustrated because they can't, but if you look, they're historically never better than 20/50. So the best reachable vision. We don't expect you to... Say it again, Francisca.
Sorry.
Oh, I don't know.
So the other thing too is, Sherry, that the new people need to understand that if a patient has ARMD, they're not going to see well. They are not, doesn't matter what you do, they are not going to see well.
Yeah. And so this points to being sure that everybody, when they're taking a patient, is doing a quick chart review first. You know, no matter how busy it gets, you should click on that patient, pull up that chart review, and just make, you know, get the basics. All right, they're not legal to drive, and their pressure's up or whatever, and it has been for the past 2 years. You just gotta get it quick and dirty about the patient before you take them in. So you can't expect them to get better than they were unless they've been receiving some kind of treatment, or they're, you know, had surgery, or, you know, whatever it is. So endpoint 2020. Best reachable vision or endpoint for each step is I can't tell the difference. I know there's some certification questions out there that say, you know, what is your endpoint? And one of the options is equally clear, but actually the correct answer can sometimes be equally blurry, you know, if you're talking cylinder and axis. So we're talking SIL, we've got the with the rule and against the rule, all that stuff. With the rule, do I want to go there with you guys? Do you want to do with the rule and against the rule? Do you want to talk about that, or should we just talk refraction? I'm not going to do with the rule. All right, never mind. So what's happening is they've got this cornea that's got 2 different focal points, right? The flat side of the cornea with astigmatism is going to have a longer focal point, like this orange focal point. Right, the steeper side of the cornea is going to have a more intense curve, which makes it more plus, which makes a shorter focal point. And so they've got 2, and so they have trouble with distance, they have trouble with near. And the cylinder correction is this space between those 2 focal points. So what we're trying to do is bring those 2 points as close together as we can by giving combinations of cylinder lenses and sphere lenses. You know, so we can fix this wonky cornea with all kinds of minus SIL, but every time we add minus, stuff gets smaller. So then you have to start combining stuff and putting plus in there to start pulling those things back together again and making the image the correct size, which kind of talks about retinoscopy too. You know, we're trying to get all of the meridians to give us a nice equal reflex coming back at you. So axis, we're going to have the axis of the lenses that we're putting in here 90 degrees away from the power of the cornea. So if they've got horizontal is the most powerful curve of the cornea, we're going to put the most power of the lens vertically. So that would be your against the rule cornea. And then if we had the most power vertically, with the rule cornea, we would have a horizontal lens correction. So the power of the cylinder is always 90 degrees away from the power of the lens. So once we drop the Jackson cross SIL in place, pardon me, it's really important that we have the axis flip wheels lined up with the axis arrows. And this is step 1. You have to refine the axis before you refine the power, or you're not going to get accuracy. So we make sure that they're lined up. And then when you're done with the power, put it back on this before you flip the Jackson cross out of there, so you don't even have to think about it next time. Red dot on one side, white dot on the other side. And we're just going to flip the wheel. I couldn't make it flip once. It had to do this big fancy flip. Better 1, better 2. And the patient says better 2. So we're going to decide whatever they say, we're going to put it where they like it. And Etta, you want to double check that for yourself, because that seemed to be the place you were hitching on. So
Yes.
pop that into your brain there. You got to make sure that you are turning that thing to the position that the patient likes best. Yes. Right. So we're looking, and we're going to rotate the axis 15 degrees in the direction of the red dot. Right. So if the red is from the wheel towards the red dot is counterclockwise, we're going to move that axis wheel counterclockwise. 15 degrees, 3 little lines. And we're going to repeat that and keep going until they change directions. All of a sudden, they're going to want to go clockwise. And when they do that, we're not going to go back 15 degrees because we just came from there. So we'll go back 10. They change directions again, we'll go back 5. And we're closing in on that perfect zone. And if they keep jerking you around, find the thing in the middle and go, it looks the same here, right? From here to here. You can prompt that. So yeah, better 1, better 2, or they're about the same. And you guys can stop me if you need to, but I think you all know this, so I'm just kind of running through it. So once we flip the power setting, right, we're moving those axis wheels 45 degrees away, and we're putting the power setting aligned with the arrows, and we've got the red or the white, and we're just going to flip, better 1, better 2, and if the patient says better 1, we're going to flip it to where they like it. And if the white dot is under the P where they like it, I like to think of the white as 0, right? We're going to take minus away and move towards 0 if they like white. So that 75 is going to become 50. If we flip and they choose the red, if you get red, they like red, we give red, right? So our 50 is going to become 75. 0.75, 0.75, if you want to get technical. We're going to keep flipping until they start jerking us back and forth. Or sometimes if we've got their glasses prescription in there and everything is fine, I'll go better 1, better 2, and or are they about the same, like right on the first flip if there's no complaints there, and offer that third option, because what we're looking for is they're the same. Because we're taking them an even amount away from what they need. And if it's not what they need, we're taking them further away on one side than we are on the other. And so this is what's making them make their decisions. And so we're always going to follow that red. If the power flip is red, we're going to give them red because they like red. If the power flip is white, we're taking red away and we're going towards 0. If we need to make a choice, we're always going to go with less minus, more plus. Right? We're going to accentuate the positive. For every click of minus SIL power, they should be able to read a line lower on the chart. If they want SIL, and their best read was 2050, and they're asking for minus SIL, you can give them a click, but I want them to read the 2040 line to earn it. They have to earn it. If you give them 2 clicks of SIL, first of all, they got to read two lines lower, but you're also now, when we're giving them minus cylinder power, we're making stuff smaller. So for every 2 clicks of cylinder power, we're going to give them 1 click of plus sphere to keep stuff from minifying, right? Keep stuff from getting smaller and farther away. And that's going to give them swimmy head when they put their glasses on. Then we're going to make sure that we put that axis setting back, put the flip wheels back to the axis setting before we take the Jackson cross out. And we're going to refine the sphere 1 more time. And it's especially important to do this if you've been playing with the cylinder power. If you're giving them more minus SIL, you're gonna definitely want to double check to see if you can get them to take a little more plus sphere at the end of the refraction. So I'll usually give them a little click, 2 clicks of plus to see if they like it, then 1, and then maybe 1 click of minus. But we're going to be very careful of over minusing. So if they're starting to suck up the minus, especially your younger patients, we're going to ask them, if you've given them more than 2 clicks of minus, you're going to start asking them, is it really better or is it just smaller and darker? If they say smaller and darker, take it back. Don't give it to them, because you're minifying things, which means you're over minusing them, and we're going to have to fix that at the end. So once we've got all that in place, we're going to flop the Prince rod down there with the near card on it, get it good and lit. And checking near vision, we're going to check if you're refracting somebody, we're going to check the near vision on every patient over the age of 35. And if it's protocol to check the near vision on everybody, check the near vision on everybody, but definitely everybody over 35, because they're going to start to become presbyopic, and it's most apparent. They don't notice it at 35. They don't really notice it till 40 or 45, but it's creeping in there already.
So is that new, Sherry, to refracting? Is that a new protocol? Because I was
No.
always told, I was always told, wait till they're 40.
That 40 works. 40 works. You can it depends on who you're working for. You know, if you're
okay.
it depends on who you're working for. I mean, usually you're waiting for a near complaint, but you know, at 40, you should start checking people's near vision. I'll give you 40. 40 really is the number.
Okay,
but
I just wasn't sure if it was like had changed,
No.
since I learned how to refract.
No, and I'm glad you said that, because 35 is my number.
Okay.
But Jacopo number, I believe, is 40. So
Okay.
thank you
Okay.
for that. And even right here, age expected correction, this is pulled off of the COT practical thing. When you guys do the visual field practical exam, you have to put the lenses into the visual field, the virtual visual field machine, and you have to calculate their age, their add by age. And so this is the 40 plus 1, 43, 125, 45, 150, and so on. So that is one of the things people underestimate the practical for visual fields. They're like, I know visual fields. But it is a little bit trickier than it seems like it should be. So your 40-year-olds, your 35-year-olds should be able to read J1 plus. Your 40-year-olds may start to creep up the chart a little bit. We're back to the beginning. What happened to the end? I don't know. And I don't know what happened to the end of that one. But we are pulling down and let me bring up this other one. Maybe I have it in here and I was just second guessing myself.
Refining your refraction.
Oh, don't talk, Malone. Don't talk. Hold on, let me
So
fix
you
this. Let me just take my voice off of here. Hold on a sec. Think I have to
You
come
guys
out.
know the base.
Hold on, let me come out of there. You guys can gaze at Hodor's lusciousness here for a second. Chord, slideshow, chord. Oh, it won't let me clear it. Why not? All right. Well, maybe I'll just play this. Maybe I'll just play this. Let me know if you can't hear it.
Refining your refraction. So you guys know the basics of refracting. So let's just go over quickly that we're starting at the top of the machine, checking the pupillary distance, the levers, the levelness of it, checking the sphere, checking the axis, checking the cylinder, and then once again, rechecking the sphere. After you use your Jackson cross, remember to pop those wheels back to the axis setting after you're doing that and put your levers back out so that the next time you get a patient in there, you don't have to poke around and look around at the wheels and, are they lined up? Are they not lined up? Just put them back when you're done, and then they will always be lined up for axis when you drop that Jackson cross in next time. Things to remember, we want to push the plus. We want to give everybody the most plus that they will accept and still be able to see clearly. Regarding the axis, don't change it too much. What they're wearing is what they're used to, especially if they've got any significant sill in their prescription. If you change that axis, it's going to make them feel funny when they look through it. So be very careful about that, and remember the, if you've got somebody who's going back and forth between 0.25 and 0, you can always put the axis at 90 and compare it to 180 and compare it to 45 and 135 and see if there's anything there. Give it a good spin, and maybe your patient doesn't have any sill at all. So we're going to give as little sill as possible. We're working in minus sill at OCB, so we're trying to get, we're going to take the best number they will accept that is closest to 0 on these minus cylinder phoropters. When we look at the sill number on the phoropters, the numbers are always red because we are always working in minus sill. If you are giving a click of minus and then you give them another click of minus, you must give them a click of sphere, plus sphere. Why? Because when we're talking cylinder correction, an astigmatic eye has 2 different measurements, 90 degrees apart from each other. And the difference between those 2, the bigger that is, the bigger the astigmatism is, it's going to pull the focal points apart. It's going to have this space of blur. So we want to try and keep those focal points as close together as possible.
And we just went over this, so I'm going to
Once
be
we've
like,
done our sphere, axis, and cylinder, we're going to refine that sphere one more time. See if you can get them to take a click of plus. Every now and again, they need a little bit of, a click of minus, but be very stingy with your minus. If you give them 0.25 of minus, it should improve their vision by 1 line. And if it doesn't, don't give it. We're trying to push the plus. So when we go from here, I want you to keep this piece in mind. Light enters a prism, which is basically, what glasses are made out of, as prisms in various configurations. And when it goes through it, it splits. White light splits into the Roy G. Biv, and the cooler colors refract at a tighter angle than the hot colors. So if you look at the angle of bend of the blue arrows and the angle of bend of the red arrows, you can see that the blue arrows take a harder turn to the right. And so we are pitting these colors against each other to figure out if our refraction is right and did we over minus the patient. So we're using from the red to the green. Why don't we use the whole thing? Because red and green are opposite each other on the color wheel, and they kind of vibrate against each other. If you look at that word red that's written in green and green written in red and vice versa, you can see they really do vibrate against each other. Green tends to pop out and red tends to drop back usually. The reason for that is we're putting, when the light splits, we're pitting these pieces of spectrum against each other. The green falls short in the eye and the red falls long. And blue falls way short in the eye. So if you are driving down the street and you see blue lights, they often look blurry. Because it tends to fall myopically. The blue light tends to fall myopically. So the space between these individual colors of light is called chromatic aberration. And so we are trying to find the sweet spot between where the red focus is and where the green focus is. The Goldilocks zone, as it were. So if you put an eye over this, You can see when the light hits the plus lens, our natural lens is a plus lens. It converges the light, but it converges the different colors. And this is, of course, a huge exaggeration of what these, how these colors split, but it makes it easier to understand. You can see that the area, the line that goes between the red and the green is that kind of mid zone. And that's what we're testing when we're trying to do that final refining of the refraction. So here's the green, and here's the red, and by doing a duochrome test or double checking for that over minus, we're trying to take these 2 points and we're trying to move them as close together as possible. We're trying to create a smaller circle of least confusion. So we're going to add plus or minus depending on which looks better to a patient. We're trying to make the big circle of confusion smaller. We're trying to make the circle of blur smaller. So how do we find this best corrected visual acuity? How do we know our patient isn't really accommodating? We try the duochrome test. And this is pitting red and green against each other. So you're going to turn the room lights on, and I suggest that you only use one of the swing lights over the exam chairs. Don't use the fluorescent lights because that kind of wrecks it. You're going to put your red-green filter into place on your projector. And I know you've been wondering what the red-green is for all this time, huh? Occlude the left eye and ask, does one side look clearer and crisper than the other? And the patient will look and tell you, if one side looks better or one side doesn't. Or do they look the same? You want to make sure that you ask that. So we're going to ask, does one side look clearer than the other, or do they look the same on both sides? Are they equally clear on both sides? So be sure to ask that part of it. If the red looks clearer, we're just going to give them one click of minus sphere to try and make them look equally sharp, both sides, the red side and the green side equally sharp. If your refraction was any good in the first place, it should only be one click out, if it's out at all. If you have to continue, again, if you're giving them minus, you got to make them prove it. If the green side looks clearer, we're going to add a click of plus sphere. And we're going to continue adding plus until they look equally sharp. Red side looks equally sharp as the green side. And now you've done this kind of found that balance, that yellow Goldilocks zone in the middle of those two focal points. But keeping in mind that if you're giving them minus, for every click you give them, they should improve. And if they don't give it. If they don't seem to understand what you're trying to do, you can let them look through one eye and give them a little bit too much minus on purpose, and they'll see that the green side looks clear. And if you give a little too much plus, the red side will look clearer. So you're just kind of going, this is what I'm asking you. You're just kind of exaggerating it so that they can understand it better. Some people need a visual, like a visual to figure it out. The final check you should try after you've finished your refraction for the distance is you're going to click 3 clicks into the plus and ask your patient, does that blur the chart? And if they say yes, you're going to go back 1 click and go, does that make it better? They're going to say yes. And then you go back 1 click towards the minus. Does that make it better? And they say yes. And then you go back 1 more click and say, does that look nice and clear? So what you've done is you've completed your refraction, you've fogged them to relax their accommodation, and then bring them back down 1 click at a time so that you've relaxed all of that accommodation and you know you're getting the right prescription. If it takes 5 clicks to make the chart too blurry for them to read, you've over-minused your patient. So a neat little trick, 3 clicks to blur, and if it doesn't make the chart too blurry to read, then you may be in an over-minus situation. So when we're talking add, how do you know? How do I know if I have to refract for add or not? It's super easy. Just look at how old they are. So presbyopia is a loss of elasticity in the lens, creating this artificial hyperopia at near. So this we're doing as a binocular test, right? Because you're never going to give a different ad on one side than you are on the other. Because all we're doing is changing a focal point of the glasses that they already have. So you need to do that evenly. But presbyopia begins in the 4th decade of life, and it's predictable. I mean, ridiculously predictable in 5-year increments. Be sure that you're not overcorrecting for near. Young people suck up minus, older people suck up plus for their near vision. Once you get them to that 20/20, you know, you might give them 1 more click, but don't go overboard because you don't want to start shortening their focal distance. People who are 40 to 44 usually need about 0.75 to +1. Usually at that age, they don't really notice it, or they may just start to notice it, or if they are noticing it, they're denying it. It's usually 45, age 45. It becomes an issue where, you know, you don't want to stretch your arm out too far and all of that. So we'll give them a +1, and as they go from 45 to 49, it may go up to a +150. When they turn 50, we're going to give them a +1.5 for add.
And this is general, you
And
guys.
as they get older, you know, in the next couple of years, we may give them a +2. 55 to 59, we're gonna go, you know, from 55 to 57, it's probably a +2-ish. And, you know, from 57 to 59, +2.25. And 60 and older, +2.25, or more. Usually it doesn't go above 2.5 because you're starting to make a focal distance really short at that point. So just, yeah, little rules of thumb. This is a very good chart to memorize. And if you are going to take your COT test, you definitely should memorize this chart for your practical exam. So record your final refraction and acuity achieved in the patient record before you check your ad. Write it down, and don't write it in a sticky and then put it in later. Write it right in the medical record. Why do it twice when you can do it once? Do yourself this favor. You may kind of roll your eyes, but do yourself this favor, because if you get lost in your ad for some reason, you're going to go, oh God, where do I start? So utilizing that outside ring of the auxiliary knobs, you can change the sphere reading by 3 full diopters. And for each click of sphere being 0.25, you can just add 3 and subtract 2 clicks. Or you can do 10 clicks or whatever it is that makes you happy. But I find just putting 3 in there and with these outside rings, and then subtracting 0.25 and 0.25. And for that, you would have an add of plus 2.50. So your basic refraction is done. You did near, you've clicked. 3 into the plus, you know, just done you checked off all your boxes. These are the things you want to ask yourself. Does your refraction make sense? Did you over minus them? You know, is it really clearer or is it smaller or darker? Did you change their axis more than 10 degrees in either direction? Careful of that. Look at the glasses they're already wearing. You know, don't go off your auto refraction. Look at what they're actually wearing. Looking at the AR, compare all three. Look at their cataract status, because ripening cataracts can create a myopic shift in the prescription. It can also create a shift in the astigmatism too, as that cataract gets thicker. So go forth, refract with confidence. And if you have any questions, this is
Okay, so we're done.
defining your
Yep. So I hope you found any of that helpful, not too boring. We've got about almost 15 minutes left, so I'm going to pull up some.
Sorry, can I just add something about that refracting thing?
Absolutely.
So I've been getting a lot lately. Patient is 20/30 with glasses on. Say they have half, minus a half, minus a half. And then I'm getting refraction. It's like +1 minus 275 equals 20/30.
Ah,
That doesn't make sense. And
so
like that's a big thing that I'm seeing.
what was the first one? What was the
Minus
original?
a half, minus a half.
And you're adding a full 2 diopters of sil.
Oh, yep.
And
The-
they're dispensing those prescriptions, and the patient's not coming back saying, "I hate your glasses, I'm throwing up." Why did you
Oh
do
no, Dr. Chan and I look at them and like we'll catch it because it doesn't make sense. Or like we'll re-refract them. But a lot of them lately, and I don't know if it's, I don't know what it is, but it's a lot.
Is it in one specific office? Is it in
Nope.
Wareham?
No.
Maybe play around with some of this duochrome stuff, play around with the fogging stuff, play around with that. It may be that you're just, somebody's getting in the habit of over minusing the patients because simply for the reason that they're not checking.
And
I
it's wicked
fog.
important to tell them to blink. Like
Yeah.
that's the biggest thing too. It's so important to tell them to blink.
Right. I fog
somebody else
every
is trying to
patient.
talk to. Say that again, Elaine.
I fog every patient.
It makes a difference.
It makes a huge difference.
Because sometimes you can get somebody, you know, all of this crazy minus power, and then you try to fog them up at the end, and you're like 6 clicks in, and they're still like EVO-TZ2.
Right.
You know, that's not good.
Yeah.
I also have one other thing. Sorry.
No
If
worries.
you have a patient, well, if I have a patient that's 20/20 fast, I push them to 20/15. Like, why not? If they're that quick with 20/20, why not try it?
Well, which direction are you pushing them in? Are you talking near
No, I'm
distance?
no distant.
As long as if you're pushing them with the plus, don't push them with the minus though.
Well, no, I'm just saying like as a general refraction,
But I
like
mean,
the ending result.
if you're trying to push them to 2015 and you're doing that by throwing crispness on there with minus, that could explain what you just described.
Oh, no, I'm not adding anything at that point. I leave it once they have the 20/20. I just want to see if they can read it.
Oh yeah, push them to
Like that's all.
as long as you're not changing the power.
Oh,
yeah, go all the way.
no, absolutely not. I just want to see, and because if they can read it fast, why not check? You're right there. It takes 2 more seconds. It's not crazy.
Can you guys see the screen?
Yes.
Topo screen?
Yes, your
Yes.
screen.
All right, let me make sure that I have Silent Duffy and Silent Wendella up.
I will shut up.
No, they just don't have microphones.
No,
Marina,
I didn't wanna, I always fog the answers.
I know you do. That's because you're excited. That's good. Hey,
I'll just be quiet.
Maureen, send me an email tomorrow with Nicole copied in, and I will throw you on that list by all means. Absolutely. You deserve to go. All right. With which patient will the use of a refractometer auxiliary cylinder lens be necessary? Don't be afraid.
Children?
So we'll A, B, C, D, apple, boy, cat, dog, because I don't hear good sometimes through the speakers.
With children? With children or not?
Well, no, can you see the 4 options that you have here?
No.
Let me reshare my screen. Can somebody answer if they can see
It
this?
stopped this screen. I see nothing here.
All right, hold on. Let's reshare. There we go.
Oh, yes.
There we go. Okay. Which patient will use needs an auxiliary cylinder lens? I'll give you a hint. How think of the cyl dial. What happens when you get to -6 on the cylinder dial? If you try to go further. Somebody, anybody. Oh my God, Bueller.
Sherry, check your
B as in
message.
boy.
Less the distance.
Check your messages, Sherry.
Check
B as in
my
boy.
phone or my chat.
Your chat.
Everything is blowing up here. Where did my chat go? What did you do with it?
There was an answer in there, that's why.
So if you guys are flipping through the cylinder dial on the phoropter, if you take it past -6, it goes to 0. So if you get somebody with greater than 6 diopters of astigmatism, you need to use auxiliary lens. And I can't, all of a sudden my chat went away. Hold on.
Wendella said 2.
Okay, I'll take that. I don't understand why I can't see my chat. I had it up. There. Oh, where? All right. Anyways, yeah, you can, if you can see the chat, you can be my chat announcer. If you guys are in a quiet room, just unmute yourselves. When using the cover uncover test during an examination, you observe that an eye deviates to an inward position, which would be noted.
Esotropia. Esotropia.
Yeah, these are tricky. You got to remember where it's coming from and where it's going. Anybody disagree?
No, it's B. As in boy.
As in boy. Right? The tropia is we can see it happening. Right? We just pop it off there and that thing comes flying in.
Esophoria is always there. Esophoria.
Tropia is always there.
Atropia. Oh, okay.
Tropia is always there. And Britta came up with a good one. Phoria, you have to force aphoria.
Oh, okay.
Is always there. You have to force aphoria by either going cross cover, cross cover, cross cover, cross cover, cross cover, cross cover. Or you can get them really tired or you can get them drunk. Measuring corneal thickness via non-optical pachymetry involves the use of
Ultrasound. B. B.
You disagree?
I say D,
B.
as in boy. Dog, sorry. Dog.
For me, it's B.
You measure corneal thickness with a spec mic, Haley?
Spec mic is for
Hold on.
to count the cells.
Wait
And
for it.
epithelial cell count.
I just had to I just took a quiz on this because I have to do my credits and I have that thing to share to send you, Sherry.
And
But
it
I
tells
just
you
had
that you
this
measure
question.
toenail thickness with a spec mic?
I'm pretty sure it did, unless that was one of
I don't think so, but look it up, and if you see it, send it to me. So non-optical is ultrasound. We are measuring with sound. Spec mic counts the individual cells of the endothelium. Slit lamp microscope is just a slit lamp, and contact mirrored lens is your goniola lens. You are applying a pressure patch. The patient's skin is oily. The patch will not stick. What is the correct procedure? Use glue.
Clean the patient's skin with alcohol, B as in boy.
I like the
B.
glue. Glue it to their
No,
head.
I don't think it's
B.
glue. I think we'd be in big, deep caca if we used glue.
Or if you whipped out that pencil eraser. Yes,
Yeah, the big red
will
ones.
alcohol will dissolve oil.
Yes.
With automated perimetry, which term designates a stimulus that is too small or too dim to be seen?
Super
Supra threshold.
B.
B.
B is in boy.
B is in boy.
Look at
With,
the end
oh, wait a
here,
minute, with automated,
right? We're talking Humphrey visual field.
right,
Stimulus
visual
too
field.
small or too dim to be
No, A.
22.
A. A. Threshold.
Anybody disagree?
Thinking maybe C.
Anybody disagree? I think C is correct. Let me check though. I could be wrong. Infra threshold. So threshold is they can see 50% of the time. Super threshold, they're always seeing it. Infra threshold, it's too dim to be seen. And intra threshold is just a distractor. We got time for one more. All right. Primary area of interest in the fundus photo of a glaucoma patient. That's kind of a contradiction of terms, but that's okay.
Well, it's A as an apple.
Yeah, anybody disagree?
Sherry, I texted you the article.
A.
Okay, good. Yes,
A.
A is correct. These
A.
are desk photos. They are shot at 20 degrees in stereo. I have Haley, Elaine,
Yeah.
Wendella, Etta, Maureen, Anna Maria, Emily, Francisca. Did I miss anybody?
No, my new manager is Mary, by the way.
Okay, good to know. I will send this out to your managers. Thank you guys so much for coming. And if you want something
Thank
specific
you.
next week,
Thank you
just
very much, Sherry.
See you at
Thank
Neon.
you.
okie dokie.
Okay,
you.
bye.
Thank you. Bye.
Take
Bye.
care.
Bye.
I don't know what is up with my screen here.